Hi, hello, welcome to VHDL Basics. Today we are going to discuss about SR latch using NOR gate in verilogHDL. If you haven't subscribed this channel yet, please subscribe this channel. Also click the bell icon for more updates. This is the circuit diagram of SR latch using NOR gate. The cross-coupled connection from the output of one gate to input of other gate constructs a feedback path. For this reason, the circuit are classified as asynchronous sequential circuit. Each latch has two outputs Q and Q bar and two inputs set and reset. This type of latch is sometimes called as direct coupled SR latch. The R and S are the first letter of two input names, which is nothing but set and reset. We must remember that output of NOR gate is 0 if any input is 1, any one of the input is 1, and that the output is 1 only when all the inputs are 0. As a starting point, assume that set input is 1, reset input is 0. Since gate 2 has input of 1, its output Q bar must be 0, which puts both the inputs of gate 1 at 0 so that output Q will is 1. When the set input is returned to 0, the output remains the same because output Q remains 1, leaving one input of the gate 2 at 1. That cause output Q bar to stay at 0, which leaves both inputs of gate number 1 at 0 so that output Q is 1. In the same manner, it is possible to show that 1 in reset input changes output Q to 0 and Q1 to 1. When the reset inputs return to 0, the output don't change. When 1 is applied to both set and reset input, both Q and Q bar output goes to 0. This condition violates the fact of that output Q and Q bar are the complement of each other. In normal operation, this condition must be avoided by making sure that ones are applied to both the inputs simultaneously. Under normal operation, both inputs remains at 0 unless the state of latch has to be changed. The application of momentary 1 to set input cause the latches go to the state and the set input must go back to 0 before applying 1 is applied to the reset input. A momentary 1 applied to the reset input cause the latch go to clear state when both inputs are initially 0. A 1 applied to set input while latch is in set state or 1 applied to reset input while the latch is in clear state leaves the output unchanged. When 1 is applied to both set and reset input, both output goes to 0. This state is undefined and is usually avoided. If both inputs now going to 0, the state of the flip-flop is undetermined and depends on which input remains 1 longer before the transition to 0. Now I am going to show you the truth table of SR latch. So this is the truth table of SR latch. If you see both the inputs are 0, then Q and Q bar will not change from the previous state. So if reset is 1, then the latch will go to the clear state, which is nothing but Q equal to 0, Q bar equal to 1. If set is 1 and reset is 0, then latch will go to the set state, which is nothing but Q equal to 1, Q bar equal to 0. If both the inputs are 1, then Q and Q bar both will become 0. This we need to avoid to maintain the Q and Q bar are complementary. So we need to avoid to setting both the input to 1. Now I'm going to implement this in verilogHDL. So this is the Verilog code for SR latch using OR gate. S and R are the inputs of this module. Q and Q bar are the output of this module. So using the circuit diagram, I am designing this SR latch. So we need to use two NOR gate. So the first NOR gate will give you the Q output using XOR of R and Q bar. The second NOR gate will give the Q bar output using S and Q are the input of the second NOR gate. Now I am going to show you the test bench for this SR latch. So this is the test bench for SR latch, where I have declared S and RR register, which is input to the SR latch module, and output of that module Q and Q bar I am declaring as a wire. Then I am instantiating the SR latch using NOR gate module. Then I am toggling the inputs inside this initial block. Now I will simulate this and I will explain with the waveform. So this is the waveform which we got when we are using the test bench for SR latch. So initially I have both the inputs S and R are 0. So it should maintain the previous state. Here we don't have any previous state of for Q and Q bar, so it is giving X. Then I am setting reset S1, which means its SR latch will go to the reset state. So if you see, Q will become 0, Q bar will become 1. Now I am changing R to 0, S to 1, which means set is enabled. So latch will go to set state, which is nothing but Q equal to 1 and Q bar equal to 0. When both the input are 1, both the output will go 0. We need to avoid this situation, but I am showing this for our uh, understanding with respect to the truth table. So it is matching with respect to the truth table. Now I am making set to 0, so which means it is reset state. So if you see, Q is maintained 0 and Q bar is going 1, which is nothing but reset state. Then again I am making both the inputs to 1, so again it is going 0 for both the input. Now I am making both the input to 0. Now if you see, Q is maintaining the previous state, but Q bar is not maintaining the previous state. So that is why we are calling this both the input is 1, that should be avoided, which will cause the indeterminate state for this latch output actually. So we need to avoid when we are giving the, we should not give the 1 for both the input S and R. So thanks for watching this video. Please like, share and subscribe this channel for more videos.